I'm going to go to this link here in my browser. So here we have roller coasters. You may have noticed that there's a roller coasters example document. This one is a little different because it has latitude and longitude. Now, the first thing to notice from a design perspective is that this is a document. It's like a Google Doc or a slide presentation document. It's something that students can work with. And the second thing to notice is that I shared it with all of you. You all got the same document and you all get to work on it independently. And that's a design decision about the classroom because that's the teacher's most common move. Give something to the students that they can work on themselves. Okay, now you will, by the way, what I'm hoping for is that you will play along with me or independently of me, and that you will ask questions as they come up for you, that there will be time for discussion, and I don't care if I don't make it all the way to the end. Now, the first thing we notice when we watch students is that they spend a lot of time here in the table, and they resist making and using graphs. So a design orientation is to convince students gradually over time that graphs are tools for making sense of data, that graphs are not tasks to be done to satisfy the teacher, they're useful things. The second, so about this graph, each of these dots are points. If I click on one, I see the item that it corresponds, or we call them cases, in the table. They're scattered because I haven't told them where to go. I can tell them where to go by choosing one of these attributes. I'm going to choose max height and drag it down to the x-axis, and now they all go to their assigned place above the axis. Now, if I hover over them, you get information. And here, I'm supposed to be bringing up design things. So I said CODAP is document-based and graphs are tools for exploration. Oh, this move that I did of dragging and dropping, that's not a discoverable move. So you might say, why did you put something so basic as not a discoverable move, something that has to be taught or shown? And the answer is because we found over many years, not just in CODAP, that though this is easy to learn how to do, and once you learn it, you don't forget it, basically. So that's our design rationale. This hovering business gives you a chance to see something. And it reinforces this idea that nothing that you're doing or making here is static. There's always something that you can click on or drag. Okay, what do these points represent? I did that already. So let's see what happens over here. Okay, so CODAP is case-centric. What that means is that we're always thinking about the case. And that's a pedagogical design decision because we know that students lose track of what the data represent. And so we keep going back to the dots represent cases and the rows in the table represent cases. CODAP is case-centric. Okay, now if I click on this maximum over here, I see, okay, that's the Top Thrill Dragster, and I see all the information about it here. Now this table is kind of clumsy, right? Because it's got more columns than I can easily see in the limited space that I'm likely to have in a school, on a school computer. And so there's another representation, and that's called the case card. So I switch to that, and now I get a nice list of these column headers, which we call these things attributes. And I get the values for the particular selected case. And if I select a different case, then I get the values for it. So, so selection is dynamically linked between all representations. Now you saw me drag max height. I can drag top speed. So I drag it over here to the y-axis. Now that animation is pretty important. It's very different than bloop, the new graphs suddenly appearing, because we need students to be able to understand what each graph, how they got from one graph to another. And if I undo that and then redo it, we see the movement of the points to their new positions. And I think I had something in here. There's about the case card. Animations help users understand what's going on. Okay, now I'm not limited to one graph, so let me make a second graph. And I look down here at these various attributes and I see type, material of track, steel or wooden. Okay, I'm kind of curious about that. So I drag it over into my second graph and I get a different kind of graph. Notice I didn't have to say what kind of graph I wanted. It's a design decision that mostly you will get something, and we will have chosen something that's generally useful. Now, so that's over here. Never ask what kind of graph to make, just make one based on the dragged attributes. And notice that, again, we have dots. We didn't make a bar chart with solid rectangles, though I could. We made a dot chart. Okay. Now, I showed you that we can do point selection, and of course, that's interesting. We see that the graph, both graphs show the same selection. Now, I can also do this marquee selection. So as I drag, notice what's happening on the right. More and more points are being selected during the drag. So that's a design decision. We decide that selection should be dynamic, not, you know, I do the drag and then I let go and then the points are selected. The selection can then become an exploratory tool in yet another way. So I said something here. Link selection occurs during the drag. Now, if I click anywhere in the white space, the selection goes away. So I've lost that information. But I can get it back because there are other places in the graph that I can drag. One of those places is in the middle. It says color points by values of type. So let's see what happens. Okay, there we are. A different way of getting that information. And we now have 3 attributes on this graph. So we're invited to be multivariate. And you can get 5, 6 attributes all on one graph. I don't necessarily recommend it, but you can go quite far, in other words. Another thing to say about that is that it's very important for any tool that students will use that it have this very low threshold for getting started. And yet, it's almost a cliche to say it should have a high ceiling, that you don't feel that you've topped out after just a few hours. Okay. Anyway, I'm going to click on, notice that I'm getting a little cue that something might happen if I click here. And I click and I see, oh, those are the wooden ones. I didn't tell you much about the context of this data. I should have started with that, but I forgot anyway. They're roller coasters. And we've seen kids from middle school through graduate school play with these data, and it's generally a fun data set to play with. Now, when I click here, of course, I see the selection here. I also see something interesting over here. Let's see, I think I had something there. So this invitation to click, I get a surprise. Not all of the wooden roller coasters were selected. Well, let me click on one of these and see if I can figure out why. Do you see why? Whoa, there's no top speed for this particular Leap the Dips roller coaster, and so it's not plotted on that graph. And there are interesting design decisions about what to do with missing data. So a design goal is to have the student feel that there's always more to explore, and that what I want to explore as a student comes out of my interactions with the data. When we present students with static information, static graphs or tables, God forbid they're in textbooks, it never feels like there's anywhere to go. But with CODAP, we want it to feel like an environment that has endless possibility. All right. Now, I click on one of these points, like this one, and I see that it's in Ohio. Gee, I wonder where the other roller coasters are. I wonder what their geographic distribution is. So I make a map, and the roller coasters show up on the map. In science investigations, geographic data is frequently of prime importance. And very often, at least in the past, students have been sent off to a geographic data tool that only does geographic data. And we said, well, that doesn't make sense. I should be able to look at data in a graph, like here, and I should be able to look at data geographically, like here. In fact, this map, if you think about it, it's a lot like a scatter plot. It's just a scatter plot that uses the latitude and longitude axes. And it has some of the same affordances as a graph. I can click select on that marquee and select more than one. Do it again. And a surprise, that thing that looked like one dot, it's actually a bunch of dots. So my design point is that geographic data types can live comfortably alongside numeric and categorical data types. In fact, there are other data types in CODAP, and one of our missions in promoting use of data in the classroom is that students get exposed to many different kinds of data types. Okay, now coming back to my my data here, I wonder, I'm gonna close the map for now just so I'll have a little more space. I wonder about this age group thing. So I've got 3 different time periods, and I can scroll through these. So there's the newest ones. There's the recent ones, and there's the older ones. So as an investigator, a data explorer, I'm interested in, are there things about roller coasters that have changed over time? So let's make a graph of age group. And I'll just use this graph. Oh, wait a minute. Why do I just have 3 points here? Because this is a data structure that has 2 levels. Notice up here in age groups, it says 1 of 3 is selected. And down here, it says 44 of 157. So we have age groups and roller coasters. If I go back to my case table, I can see another representation of this. And now I'm going to make the case table bigger so it becomes a little more obvious. We see here are the 3 age groups, and each of them has a bunch of roller coasters that are in that group. So this is a kind of hierarchical structure where we've grouped things. Now, when we initially got into this quite a bit of time ago, we worried, of course, that hierarchical structures might be difficult for students. And so we did research to find out how difficult they were, and the result was surprising. So we did interviews and questionnaires with middle school, high school, and college. And we looked across those groups, and we found that, and we asked them to make their own data structures. And we found that many of these students made hierarchical structures, that it was a natural thing for them. And in fact, the younger the students were, the more likely they were to make a hierarchical structure as opposed to a flat row by column structure. We think, without proof, that that's because the older students have been trained by spreadsheets to view data as something in a row by column. But the take home for us was, and we've done more research since, that middle school students can understand and work with hierarchical structures just fine. It makes intuitive sense to them. That's what we found. Okay, so I'm going to undo, and I'm going to undo again. And notice that undo and redo is a very important pedagogical tool. You yourself, as you use any productivity tool, if it lacks undo, don't you feel a little bit nervous? Like I'm gonna break things and I'm not gonna be able to get back where I was. So
Bill,
undo.
one question.
Yes.
With the groups, can you turn those groups into just attributes in those rows, and can we group by other columns? Is that
good question? Well, let's try it out. If so, I should be able to do it by dragging, right? Do you see that it looks like maybe something will happen when I release? And now I've got a totally flat structure. And I'll just go back to the table so we verify that. And gee, I wonder what would happen if I put state over here. Oh, now I've got 32 different states. Does that answer your question,
Thank you.
Michael?
Yes.
And another pedagogical goal, of course, is that students become able to understand many different representations. The linked nature of these representations is one thing that helps you do that. Now, suppose I want to look at how one of these things changes over time from older to recent to newest. Would someone choose an attribute that we could look at, a numeric attribute? Just shout it out.
Drop.
Drop, okay. And what do we think is going to happen over time?
Become higher.
Oh, I'm getting into my teacher mode and trying to elicit interactive discussion. Probably not a good idea. Oh, did you see that? The 3 dots became many dots, and they placed themselves into these 3 groups here. And what do you think? Oh, I want to draw attention to this design item number 15 here. Data are not flat. Allow for structures other than row by column. So when you're modeling the world, you will have more difficulty if you restrict yourself to only flat structures than you will if you allow other kinds of structures. What's the next one? Now watch this closely. Watch the animation.
Oh.
It wasn't quite what you want, right? I tell you what I want. I want those 3 points to explode into their own separate subpoints, if you will. So that's, there's always room for more and better animation. You will find that after a while, you don't pay that much attention to it, but that's because you've become expert with CODAP. And we have to think about the learner and their first encounters. And so making suggestions about animation is another way to help improve the tool. Now, I look at these 3 distributions, and I think that the newest distributions, that there's a trend here in increased drop. I bet you agree with me. Now, I haven't used this thing over here, which we call the inspector palette, at all yet, but it actually turns out to be an extremely useful tool for changing the thing that it's next to. And if I go to the ruler, lo and behold, I have a bunch of things that I can show on the graph, a bunch of measures. So I'll choose the mean. I show the mean. Oh, the trend now becomes quite pronounced. 77, 112, 157. Well, here's another nice suggestion that you could make. There's no units showing there, but we know what the units are. Shouldn't it say mean equals 157 feet? Notice that there are units over here for the numeric variables. Okay, so that's nice, but what if I want to have a record of these 3 numbers? Well, I can come over here to the case table and say, I want to make a new attribute. And I could make one at this level, or I could make one at this level. Oh, I want to measure the mean drop of each age group, so I should put it at this level. And this is not necessarily an easy thing to understand, but I'll call it the mean drop. Now I have to calculate something. Notice we haven't had to use anything but point and click so far, except I just typed that name. But if I click here, I get a menu, and I can edit the formula for this attribute. Now, if I just start typing like mean, okay, that's helpful. I see that CODAP probably understands mean, or I can go to in here and look at the statistical functions, which I may not know to go here, but if I look at them, I see a whole bunch of them. And I can come over here and click on the information button and learn about the mean, how the mean function works. Now, notice how hidden this is. That's deliberate because we know that 98% of our users will not use formulas. We would love them to learn to do that, but we know from past experience that it's a fairly advanced feature. So we hide it away so that it doesn't get in the way of students. They can be shown how to do it and then make use of it in the contexts where that's important. Formulas are powerful, but hide their complexity, was my point there. Okay, so I want to put the mean in, and I want the expression, this is kind of a strange word, but I want to know the mean of the drop. So I could type drop and press tab, or I could look in this list of things that I can use. So I apply it, and now I have 3 values, which I can go through one at a time here, or if I'm looking at it in the case table, I see listed. Now this is an attribute. That means I should be able to plot it. If I drop it down here, I see the 3 values. The points are still clickable. Everything is still connected. Now, I come over here and I notice that, let me go back to the case card. I notice that a lot of these numeric variables have units, but my mean drop does not. So I want to put units on it. And that I do by editing the attribute properties. So I could add a description if I wanted. I could say, I want to force this always to be categorical. Well, that doesn't make sense. But notice that CODAP usually figures out the best type for something. But here I get to put in units. Not units, feet. And I could change the precision just for fun. I'll change it to 1 decimal place and I apply. And now I see 112.5 feet. Okay. So the point here is that as students, users, teachers, curriculum developers get more familiar with the tool, they should become more and more able to communicate to their audience. So we as a group will use CODAP to communicate to the teachers and students we're working with. We need to be doing the things that will help them understand the data that they're working with and help them help their students to understand the data.